right, so we're going to pick up where we left off with 9.1. So this will be 9.1 part 2. So it says the angles 30, 45, and 60 occur frequently in trigonometry. You can use the trigonometric values for these angles to find unknown side lengths in special right triangles. So these are the special right triangles, what you would get when you are taking the sine, cosine, tangent, cosecant, secant, cotangent. You don't have to memorize this box. There are ways that we can come up with these values using our special right triangles. So you'll see the special right triangles on the SAT. These two triangles are actually given to you. They give you 30, 60, 90, and 45, 90. But you have to know how to use them. So I know that you've seen this in geometry before, but we're going to refresh our memories a little bit. So depending on where the 30-degree angle is, it could either be at the top or the bottom. Things will shift around. So we have a 30, 60, 90. Across from the 30, so the one that is opposite from the 30-degree angle, that is going to be just your standard, we'll call it A. So that's your base side. That's where we start. Across from the 60-degree angle, whatever your A is, it's going to be A times square root 3. And then whatever's across from the 90-degree angle, your hypotenuse, is going to be 2A. So this is our 30, 60, 90 triangle. The other special right triangle is 45, 45, 90. So in a 45, 45, 90, the two angles are 45. The two acute angles are 45. And we have a 90-degree angle. Across from the 45-degree angles are going to be the same thing. That's our starting value. That's going to be just A. And then across from the right angle, your hypotenuse is going to be A times square root 2. So let's look at example 3 on the next page. It says find the value for x for the right triangle. So it helps to label what we have. We know that across from 30 is our starting value, just A. If one of our angles is 30, that means our other angle is 60, and across from 60 is going to be A square root 3. And then what's across from the 90-degree angle? What's our hypotenuse? 2A. So it gives us that 8 is equal to 2A. It gives us 2A is 8. So if we were just solving for A, we'd say 2A is equal to 8. What would I do to solve for A? Divide by 2, so A is equal to 4. So A is 4. That means that this side is 4, and this side is going to be 4 times square root 3. So x is equal to 4 square root 3. So you just plug in your A into your other two values. You're just trying to find x, so you just had to find this side. Sometimes it'll ask you for both sides, so then we would know this side. But it would probably say like x and y and ask to find both of them. All right, let's do it again. Find the value for x in the right triangle shown. So if one of our acute angles is 45, we know that the other one is also 45. It's going to be a 45, 45, 90 triangle. Across from the 45s are A. And what's across from the 90? A square root 2. So A square root 2 is 6. I want to figure out what just A is. So how would I solve for A? So I'm using this to solve for A, the equation that I have. So A square root 2 is equal to 6. How do I get A all by itself? If it's being multiplied by square root 2, how do I move that to the other side? Divide by square root 2 on both sides. So A is equal to 6 over square root 2. Could I leave my answer like this? No, what do I have to do? Rationalize. Always rationalize when you have a square root on the bottom. So I'm going to multiply the top and the bottom by square root 2. So we get 6 square root 2 over 2. Can I simplify this? Awesome. We can divide the 6 by 2, so that gives us 3 square root 2. So A is 3 square root 2. So we would take this, plug it into the A. So what does x equal? 3 square root 2. So if it wasn't a special right triangle, it would have to give you 2 of the sides, and you use Pythagorean theorem to find the third. But if it is a special right triangle, it'll probably only give you one side, so you can't use Pythagorean theorem. You have to know your special right triangles. We're going to practice another. So let's say we were given this triangle. We have 30 degrees, and this side is going to be, let's say 10. So this is just an extra example. And let's say that this is x. So we have to find x. What would I need to do to find x? So let's label our sides first. What's going to be across from 30? A. If this angle is 30, we know that our other acute angle is 60, so what's across from 60? A square root 3. And then what's across from 90? 2a. So we use the equation that's already given to us. So we're going to use this one, the one that we can actually solve for a, so the one that it gives us information already. So we have 10 is equal to a square root 3. How would I solve for just a? Divide by square root 3. So 10 divided by square root 3 is equal to a. Could I leave my answer like this? What do I have to do? Rationalize. We're going to multiply the top and the bottom by square root 3. So we get 10 square root 3 over 3. So that's our a. What would I do next? Plug it in to the a. We're going to plug it into the one that we're looking for. That side, x is equal to 2a. So we have x is equal to 2 times a, which we know a is 10 square root 3 over 3. How would I multiply this? I just multiply it to the top. So remember, when you multiply a whole number by a fraction, you multiply straight across. So it only gets multiplied to the top. So we have 20 square root 3 over 3. So this would be x. That would be our answer. So another extra example. We'll have a 45, 45, 90 triangle. And let's say that this side was 2 square root 3, and it asks us to find the hypotenuse. So we want to start by labeling our sides. What's across from the 45? A. What's our hypotenuse? A square root 2. So do I know what A is equal to here? Yep. So what do I do with that? Take it and plug it into A to solve for x. So x is equal to 2 square root 3 times square root 2. How do I multiply this together? Perfect. I can multiply the radicals together. So if they're both inside, we can multiply them. So we have 2 times square root 6. So that would be our answer for x. All right, so another example. Let's say we have, we'll put 60 down here. Let's say this side is, what's a number? 5. So the side is 5, and it asks us to find, let's find the other two sides, x and y. The hypotenuse and the other side. What would I do first? Label each side. So across from 60 is what? A square root 3. What's across from 90? 2a. And then what's the other side? Just a. We know that this angle is 30 because if the other acute angle is 60, the other one has to be 30. So then the one across from 30 is just a. So what would I do next? Plug them in. So we know that 5 is equal to a, so we're going to plug that into all of our a's. So what does y equal? Y equals 5 square root 3. And then what would x equal? It would equal 10. 2 times 5 would be 10.